All right, here we're looking at mesh analysis when we have the particular case of having an interior current source. So the interior current source is here. That means that it's not on the edge, but it's actually inside the mesh circuit, meaning there's two different meshes that interact with it. And we'll find that if we apply the conventional mesh analysis, there's a little bit of a problem in writing the KVL, and we'll talk about how to overcome that using a super mesh. So let's start with the first analysis, and we are going to first identify unknown meshes. We're going to identify the meshes by drawing them in the circuit here. So we'll start with this top one. We would have a mesh going in this top one. We're going to call that I1. And then we're going to identify a second one here. Let me use a slightly different color. This mesh here. And this would be I2. Okay, so we have two meshes, and so we may have up to two unknowns. We notice that we have this interior current source, and so we'll see if we have one or two unknowns, and we can do this by applying our source suppression. And so if we suppress our sources, then we will short this voltage source here, and we will open the current source here, and we'll see the result of that is actually there's only one big loop, and I'll kind of draw it on the outside actually here. One loop here. So that means that there's not two. So that means that there's actually only one unknown here. And so let's kind of write that down. Let me erase, write that down over here. So we can use source suppression. Tells us that the unknown here, let's say it's I1, we can just choose one. I1 is our unknown. And this is because if we look at the other circuit, we know that if you're looking at IS here, IS is equal to I2 minus I1. So once we know I1, we automatically know I2. So there's only one unknown mesh current. Okay, great. So then we have our one unknown. So that's actually good because we want to, fewer unknowns is better. So now we're going to apply KVL, Kirchhoff's voltage law. And let me see if I can erase some of this stuff here. Okay, I erased a little bit too much, but that's okay. So it's going in this direction. Okay. And so what we're going to do is if we were to apply KVL, let's say on I1, we would see, and I'm going to put some positive and negatives around here. We would see that following the direction, positive, negative, and then positive, negative here. And let's also just put in the positive negatives with the I2 direction. Okay, if we were to follow KVL around I1, we would have a little bit of a problem. Let's just write it down. We would get that we have, let's start from this corner, upper left-hand corner. If we go up, so we'd get 0 equals capital VS, and then we'd be going down on R1, so minus R1 times I1. And then we would get to this current source. We don't know the voltage drop over it, right? Because a current source is creating a constant current and it can provide any voltage. So we don't know what voltage is going to end up at. So we can't we don't know the voltage that's going to be across that jump. So, we could, let's just look at the approach. It could say, well, what if we make I2 the independent, so the source that we're solving? Well, we would be able to define the current drop over R4 and over R3, but we wouldn't necessarily, again, know that voltage drop over IS. So we end up with the same problem. What we can do is apply KVL around, we just kind of go around the other one, because we know KVL is always true, any loop that you have. So we're actually going to use this super mesh, the black loop here, and we're going to go around that whole mesh to write our KVL equation. So I'm going to erase this part. So we're going to call that, it's going to be our super mesh, and I'm sorry about my writing, my pen is broken. And so this would be I1 and I2. Okay, so now we apply this one, this giant KVL. It's probably going to take 2 lines. And we have VS, so we'll start here. Again, VS, then we did over R1. And now we're going to do over R4. So we're going to minus R4. And the current through this one is I2. So you don't want to use the right currents there. And then we're going to have minus R3, I2. And then go to the next line here. R2, the only current going through R2 is I1. And we're back at the corner again. So we actually written our KVL equation based on the super mesh. And so let's double check that we have everything in terms of independent and dependent currents. And let's see. So I'm going to use a different color this time. We're going to do light blue for the known. So we know R1, we know R4, we know R3, we know R2, we know VS. Those are all given. And on the right we have our unknown is our I1. So we have I1 here, I1 here. And we do have 2 I2s. What we would do is replace that one with using our voltage source equation. So let's just write that out. I'm going to write that in green. So we would have I2, I'm just going to write down here, I2 equals IS minus I1. And we put that into both here and to here. Once we do that, we have IS, which is known because it's a current source given, an independent one. And then I2s are all now replaced with I1. And so we would be able to we have one equation with all in terms of I1 and known variables. So we have one unknown, one equation. And so then we can use that to solve our system of equations. So we just solve it like a math problem here, and you'll have to just substitute them in, but I'm just showing you the process. And then it becomes a math problem and you can solve it, and you'll be able to find I1. Once you know I1, you can use this equation to find I2, and you can define all the voltages and current in the circuit to figure out whatever voltage or current you're looking for in the circuit.